I'm going to use this problem to illustrate what happens when you have something like 4 theta and the kind of t-chart that you should do when graphing that. I'm going to make a 3-part t-chart of theta, 4 theta, and then the cosine of 4 theta. And I also am going to set up my graph to be what it needs to be. And I know that I should have paused and done that, but I'm just going to take the time to do it right now. Put marks here, 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 and here to denote the quadrants. Then I'm going to put marks here, here, and here to denote my common angular values that we tend to use, the 30, 60, and 90, or 30, 45, and 90 degree angles in each quadrant. And then finally, I'm going to mark the radii I'm going to use. This is a maximum value of 3. There are 18 marks here, so we're going to make every 6 marks be 1. 1, 2, 3, 1, 2, 3, 5, 6. Getting that inner one can be tricky. 4, 5, 6, and there. And I might put a little small tick mark here, here, and here so that I've got halfway points. I'm just going to put that on all sides. So 6, 6, and then little mark here for 3, little mark there, little mark there. Okay, 2 to go. There. 1, 2, 3, 4, 5, 6, and there, and then here, and here. And then again, little marks there, little mark there, little mark there, little mark here, little mark here, little mark here. Okay. Now the grid is structured out. Let's go back to this. So 4 theta is what I'm going to start with. I'm going to go from 0 to pi over 6 to pi over 4 to pi over 3 to pi over 2. Then I'm going to keep going. I'm going to do a couple of these. Actually, I'm going to do 4 of these because 4 theta is going to really, really be terrible. So we're going to keep going around the entire grid circle. But trust me, this is not going to be as bad as it looks. At least it's going to look terrible right now. So 2 pi over 3, 5 pi over 6. Oops, forgot. 3 pi over 4. 5 pi over 6 and pi. Let's keep going. 7 pi over 6. 5 pi over 4. Then 4 pi over 3. Then 3 pi over 2. And then I'm going to keep going one more time. So, or one more quadrant. So this is 5 pi over 3. Then 7 pi over 4, then 11 pi over 6, and then 2 pi. All right, next I'm going to divide each of these by 4. 0 divided by 4 is 0. This is pi over 24, this is pi over 16, and this is pi over 12. Freeze. We actually, on this graph, only have pi over 12. I've only got that right here at pi over 12. And on the other graph, the one that you have that's the 2 per page, it's down to pi over 36. So you can try to graph a pi over 24. I probably would advise against it, which means that when I start dividing these out, I really can't graph a lot of these. I can graph this, I can graph this, but I can't graph too many more of them, which means that let's do a couple of other ones. Let's see. Pi over 2 is pi over 8. That's going to be out. 2 pi over 3 is going to be, if I divide it by 4, that's pi over 6. I can't graph pi over 8. I really can't graph this one because it's going to be over 16. This one's going to be over 24, but this one's going to be pi over 4. I can't graph that one. I can't graph that one, but this one is going to be, let's see, if I divide it by 4, I'm going to get pi over 3. And then let's keep going. Do I have another pi over 12? 2 pi over 3 pi. Okay, well, let's keep going with this one. This is going to be over 8. This is going to be a 5 pi over 12. We can get that one. I can't get this one. I can't get this one. And then when I divide this by 4, I get pi over 2. Okay, now I'm going to take the cosine of these different values. Actually 3 times that. So 3 times this is going to be 3. Then, then cosine of pi over 3 is, I can't believe I still need to draw this out, but I do. That's 3/2, so 1.5. Then the cosine of 2 pi over 3 is negative 1.5. Then the cosine of pi is negative 3. Then the cosine of 4 pi over 3 is negative 1.5. Then you have the cosine of 5 pi over 3, which is positive 1.5. And then you have the cosine of this, which is back to 3. All right, so let's try to graph these because we are graphing angle and radius. So it is going from 3 to, I'm going to graph this one now. That's pi over 4 negative 3 is going to be here. And halfway in between that, at pi over 12, well, not pi over 12, pi over 12, it's going to be at 1.5, which is going to be right here. And then pi over 6, it's going to be at negative 1.5. All right, so watch how this happens because this is going to help you get the whole thing. This is a very, very heavy reasoning of logic here, is that we're going to that. And I'm going to stop. I'm going to graph this part right here because it is going to go from here to here, cross through there, connect with that, and connect with this. Okay, then we're going to do another arc because pi over 3 is going to be negative 1.5 as well. Then it's going to go to this 5 pi over 12. And 5 pi over 12, if I count them, 1, 2, 3, 4, 5, that's this one right here. So 5 pi over 12 has a radius of 1.5. And then pi over 2, 3. So watch how this second arc is drawn. Here, back to there, cross through the origin, come back up, and right back up here. Now, I'm willing to bet that you can actually, without putting a T-chart, go ahead and figure out logically how these other pieces are going. Meaning, and I'm going to do it for you right now, this next piece should go from here and then connect. Oops. So these arcs are going like very, very, I want to say wide. So we should get one going from here back down to here, and then popping over into, let's see. So this goes here, then the next angle over goes negative. So this is going to go negative here, maybe negative 1.5. And then the next one over becomes this. So our next bit is going to look like that. And then we can do the same design again. There's a point. Slide over again. We get the opposite point happening on the other side. So that's right here at 1.5. And let's see. Oops, nope, that'd be right here at 1.5. And then out to 3 here. So it's going to go like this. And then out to there. And then we're going to do the same thing as we continue around. We got half the image, so I'm going to keep going. Here, 1.5. Then the next angle over. See, I'm tracing this to the other side and getting 1.5 right here, and then back out to 3. So we're going to go down. Let's see, did I get that right? I did. So this is going to go down, come up, cross, and end up right there. Whew, this is tricky. Then we're going to do, I'm going to continue to sweep this. So 1.5, keep this angle going to the other side, 1.5, and then back down to 3. So back down like that. Then 1.5, trace this to the other side, 1.5, and then to 3. So this goes down, crosses, comes up like that. Let me try that one more time. It's actually not as easy as this looks. And let's keep this going. You should see that we're almost getting to the point where we're filled in. So point there at 1.5, cross over to the other side, put a point at 1.5, and then go to 3. So this goes here, here, down, over, and up. And there we go. I have a rose. This has 8 petals, which is what I would expect, because if the number here is even, we have twice that many petals. I could have drawn that a little bit better, but honestly, that is pretty freaking amazing. But I hope this process of just seeing we're only graphing a limited number, and then you are using symmetries to get the rest of them, and a lot of logic. So trial and error, and keep it going.